So thank you very much for coming here. My name is JUKKA PUPUTTI. I work for F-Secure. My colleague Knut Vatneström will be presenting part of the presentation. So we'll do it half and half, roughly. And well, today we are talking about post-PC era. So what is happening? What is the security in the post-PC era? And well, let me start telling why I think we are already living at least the beginning of the post-PC era.
So I was just about to start telling why I think we are living in the post-PC era, or at least the beginning of it. So we are actually seeing the PC sales falling. I'll be showing you some real numbers. So what are really the reasons for PC sales going down? And I think that it's, well, there's many various reasons. But really the PC manufacturers, they are not able to give the wow effect anymore. I mean, you look at the different notebooks, and there's not really that big exciting things. Windows 8 was not able to excite the consumers. It's not something that people go and I need to get this right away. There's not really something to drive the PC sales from that side. On the other hand, we are seeing that people are pretty keen on the tablets, different smart devices. So those devices, the sales of those are in the increase. One factor to slow down the PC sale is deployment cycles in the companies. Maybe you have seen that in your companies, that you want to use those PCs a bit longer, just a little bit longer. They are still fairly okay. We don't need to replace it. There may be some budgetary constraints. You may be willing to spend your budgets on something else than renewing your PCs. And on a global scale, that is working against the PC sale. If the life cycle of a single PC is longer, then the people are not buying new ones. The thing that I will be talking about more here is virtualization. So virtual technologies, client-side cloud computing, those are things that are also slowing down the PC sale. So let me show a little bit market data from different angles. So here you see the PC sales globally, first quarter this year and last year. And as you can see, there's like a 14% decrease year over year. So from last year, the PC sale dropped 14%. Now looking at the previous quarters, the year over year decrease, it's getting even bigger. So 14% on first quarter. It was still only a few percent, 8 and 1% on the second quarter of last year. Still first quarter last year there was some growth, but now since then we have seen the PC sales are going down. On the other hand, we are seeing smartphones. The smartphone sale is increasing. Okay, different feature phones, there we see a decline, but smartphones are selling more and more. And here another view to the market. Connected devices, different devices that are used to connect to the internet. What are the fractions or proportions of those devices that are sold? So you see smartphones, that's the light blue graph on the top. So you see year over year, they are increasing in numbers. Tablets start to increase, already a fairly good amount sold, while then your portable PCs and desktop PCs, the sales is really shrinking. So that's why I'm saying that now we are in the post-PC era, or in the beginning of that. I was referring to the virtual technologies being one of the factors. So what is now really the virtual technologies? We see actually many technologies, many things are called virtualization. So it's really a family of be it server virtualization, application virtualization, desktop virtualization, which is probably the biggest influencer on the PC sale decrease. Presentation virtualization and profile virtualization. So many different technologies. I'll actually be mainly talking about today about desktop virtualization. Couple of terms that we are going to be using today. A virtual machine. I don't know how well you are into virtualization. So virtual machine is basically a machine that is a software implementation of a machine that is running on a host platform, executing programs like a real computer. The platform is called a hypervisor. So hypervisor is providing a platform for different virtual machines. So you can run several virtual machines, different operating systems on a single hypervisor. Virtual desktop infrastructure, VDI. That's the desktop-centric service where we are hosting user desktops or desktop environments in the server, remote server side, and accessing them over the network. So these are a little bit of background and terminology, just in case that somebody was not familiar with them. So now, some issues that I wanted to touch upon. So what are the issues that we are looking to be solved? What are the things that virtualization can actually be solving? One of the industry trends or trends we are seeing is bring your own device or choose your own device. So people bringing all kinds of devices to the corporate environment, and virtualization can actually be one way to help or solve this topic. That's a topic for you if you are the IT managers. You probably are struggling with managers, of course, wanted a long time ago to start using their iPads, and then they brought all kinds of devices, and the cooler the device, the happier they are to bring it into your environment, and you need to be managing those. And of course, you never saw the device when it first came to your network, and some big manager says, hey, this is what I'm going to use. So virtualization can be one way to solve that issue. So you can just deploy a virtual desktop on some of these devices. Actually, my colleague was doing a demo in the workshop room earlier today. He was demonstrating also or showing that we can run Windows desktop on an iPad. So that's something that you can set these managers free with their iPad, and they can use all the applications they want if you use, for example, virtualization technologies. So having a VDI client there. So now other issues, other topics that we want to be solving. I was touching upon the hardware budgets, budgetary constraints or cost reductions. Now, if you think of your old workstations, actually, if you use your old Windows desktop running XP, the users are probably complaining that this is damn slow machine. But if you start using that as a server or thin client for your VDI, then all of a sudden that old machine can serve the purpose that it's still running there. So you can run all the applications using that, or the user can access all the applications from that device, which is already the wheels are falling off, and the device is really old. But using VDI technologies, you don't really need that much of resources in the desktop. So that's one topic with the cost reduction environment. We can use those old machinery still if we go into virtual technologies. And then of course what virtualization can bring is elasticity or flexibility. All of a sudden deploying a large number of Windows desktops can be done fairly quickly. You can just copy copy the golden image and deploy new desktops. So imagine if you would have to do that in the physical world with what you can do in the virtual environments. It's going to be fairly much easier to deploy 1,000 new desktops with the new operating system, for example, compared to the old world. So then looking like what kind of technologies are companies going to be deploying in the close future, or some of these technologies you see that they are already widely in use, like web applications. 49% are already moved to those, but then you see that companies currently in the process of moving or planning to move it within the next 12 months. You see, for example, virtual desktops. There's fairly big amount of companies going there, application virtualization, and so forth. So Gartner, for example, they are saying that there's really a steady growth of VDI technologies during the next 3-5 years. So who are the players in the VDI market? Just a quick look. IDC, Gartner, they are showing the same big players. So we see VMware, Microsoft, Citrix, they are the main players. But you see there's a lot of smaller players also appearing on the market. But currently, as we see the market, these three big ones are the main players and the ones to really watch out for. But we don't know, maybe some of these smaller blobs will start increasing and gaining importance in the market. So that's something that we need to bear in mind. That there may be then environments that we need to be looking after where you start seeing different technologies and some of these new players coming to even your environments. Another view from Enterprise Strategy Group of what are the important IT priorities over the next 12 to 18 months. Well, for this crowd, probably interesting to see that information security initiatives, they are on the top. But then server virtualization already on the second place there. What I'm pointing out here, desktop virtualization, it's down on the list, not on the top, but especially if you look at the mid-market, so 25% are looking into going to desktop virtualization in the near future. So that's one of the most important initiatives actually on the mid-market, and still on this list fairly high for the bigger enterprises or bigger players. So truly, I believe that we are really going to be seeing a lot of new VDI implementations. Here, IDC data on the software market. What is the growth, year-on-year growth on total software we see on the top, but then pointing out here on the bottom, virtual client computing, 12% year-on-year growth, virtual machine and cloud system software, 18% growth. So another view on the market is there, the different companies, organizations are moving into these technologies. So what is then the problem? Well, for you guys, if you are managing environments, let's imagine you're managing an environment where there's a couple of mergers that have happened, or different units have been managing their own IT in the past. So you can be looking into quite messy environment. You may have different physical platforms in your environment. You can have different virtualization technologies in use. So how do you then manage all this? And just to make it even more complex, now all kinds of mobile devices or tablets are coming into play, and there you see, as mentioned, different VDI technologies, and it's getting harder and harder to manage. So I would say that for the security manager, this is really going to be a big headache. And why is that? Well, okay, You may think that, okay, a virtual desktop, that may be more secure environment, but not really. It's a desktop as a physical desktop as well. So you really need to take the security seriously and think hard on how do you manage the security on those virtual desktops, just like you manage the security on the physical machines. And you also need to be taking into account the patching the software. So it's not only the virtual desktops that are kind of out there, but also the golden image which you are using to copy. So you need to be updating the golden image fairly often, and keeping that in mind, that the golden image is used to really create new machines. So a virtual desktop, as said, you need to consider the security just like in the physical world, but there is some different considerations, and this is the part that my colleague Knut Vatneström will be shortly talking more about. What are really the specific requirements in the virtual world? What kind of security topics or possible pitfalls we are seeing in those environments? I'll start a little bit on that topic from looking into the performance versus protection question. Same thing in the physical world. You need to be thinking, okay, if you increase the protection level, typically that ends up chewing on your performance. So the better protection, that very often means that performance will be worse. You will be having slower computers and so forth. And the same thing you need to be thinking in the virtual worlds as well. Knut will be looking into this topic, how to ensure we are not getting performance hits in the environments while keeping the protection level high. And what are the specific things that we need to remember in the virtual world, how to get the highest possible protection level. A bit of advertising here before I hand it over to Knut. So F-Secure, we actually are an old-timer in the market. Next week we will be celebrating our 25th anniversary. So as an antivirus company, I would say that we are really a dinosaur. And while I was referring to high protection level and still good performance, I'm happy to point out that recently we have been getting in the independent tests 100% real-world protection levels. That is really good achievement. And Knut will be touching upon how can we keep the same 100 or close to 100% protection level also in the virtual world. We have been also getting very good marks on the performance. So beating the industry average on what is the performance impact of our products on the endpoints. Well, AV-Test was giving us the Best Protection Award last February and also a year ago, and also Forrester was saying that our strategy for the corporate security is the best in the world. So these are a couple of things I wanted to just highlight here in the middle before handing it over to Knut to go more deeply into the technologies and what is our answer in the post-PC era to security.
Okay, thanks Jukka. So what Jukka explained, I guess, is that we are on a path to virtualization. That's just a fact. What does that mean for security? Jukka started on that topic already. But in our opinion, F-Secure's opinion, virtual environments need to be secured just as much as physical environments do. There's really not that big a difference. Jukka gave the example like of the CEO that brings in his new iPad or whatever device and wants to use it inside a network. And that's really the problem if you think about it with virtual environments, because what is the security problem normally? it's users. Users do things that they shouldn't do. They go to websites that might be hosting malware. They click on socially engineered emails, might be victims of phishing attacks, and it can normally be tracked down or back to a user doing something that it shouldn't have done in the first place. And what do you do with the VDI? Well, you're bringing your users actually into the core of your network. Because if you think about it, with physical machines, it has kind of been easier to separate the workstation and server sides of the network. So you can kind of firewall the users away from your data center in a sense. But with VDI, you're actually bringing your users into the very heart of your network. So that's something to kind of keep in mind. So all the security considerations really that apply to physical environments equally apply to virtual environments, but there are also specific challenges related to virtual environments that should be considered. So what are those? We have at least conceptual attacks called blue pill attacks that actually is malware trying to compromise the hypervisor layer. So kind of getting control of the hypervisor itself. We're not seeing really these kind of attacks like right now, that there would be a lot of malware written to do this, but it has been shown and proved that these are possible. So that, of course, is the most scary thing, that, well, if your hypervisor is compromised, then it doesn't matter actually what you have on the endpoint or the virtual machine, because you can do pretty much anything. There's also, like Jukka mentioned, with VDI environments, you are basically provisioning desktops based on what we call a golden image. So that golden image is something you start all desktops from, and that needs to be kept up to date. So that's usually a manual task. It's not that easy always to automate that, and that is a problem, because how do you patch, for instance, software against vulnerabilities efficiently when you have a golden image? Then it means a lot of manual work just to keep that up to date. And there's other considerations as well, like if you are using a hypervisor that supports scanning from the hypervisor layer, if that machine is copied to another hypervisor that might not have the central server there to do the scanning. I'm actually thinking of the Vmware environments where you have vShield offering those scanning services. And if you move a virtual machine to a VMware server where the special virtual machine providing the scanning services is not running, there is basically no protection for the virtual machine. So there's things to consider in VDI environments. And one of the things that is often a problem for the IT administrator is when he's looking at solutions to deploy to virtual endpoints, he's normally faced with a choice: am I going to use a thick client or a thin client? Thin clients are often referred to as the agentless approach, and those are very light, but it comes at the price of security, as I'll show you in a minute. If you go with a thick client, then you will have other problems. One is one I try to illustrate here with the so-called AV storm example, that when you provision a new virtual desktop and you start up the security endpoint, it will want to update itself, and this creates a huge demand on the update server. It wants to pull a lot of engine and signature updates and install those locally. And when this happens on many machines simultaneously, it's a huge load, or it takes a huge load on the server. So that's one very common problem. There's a number of approaches how you can kind of deal with that problem, how you mitigate it. one is the approach that I mentioned, that if the hypervisor offers possibility to offload certain scanning tasks like VMware does with vShield, that is one option, but it comes at the cost of security in most cases. The other is that you would maybe try to delay the actual updates, that you would kind of either randomize them or make them not happen instantly when you boot the machine, but these are also workarounds. They're not ideal solutions to the problem. So it's a bit of a dilemma, and I took also here a slide to talk a bit about VMware Vision, because that seems to be the most common hypervisor in use right now that offers these APIs to do scanning tasks. So you have vendors that are supporting this API, and VMware was very early in this. They offered first VMsafe interface, which has since been discontinued and replaced with vShield, which essentially allows you to do signature-based detection, so file-based scanning on virtual machines through the hypervisor layer. So in VMware vShield, instead of installing a security endpoint like an antivirus client on the virtual machine, you let VMware scan files through a special driver that is installed together with VMware tools. So whenever a file is accessed on the virtual machine, it is scanned by this VMware's driver, and it's scanned not on the virtual machine itself, but it's sent to a central scanning server where it's scanned, and then it decides whether it's a clean file or not. So this is very efficient and good way to do signature-based scanning or normal file-based scanning, but it also doesn't offer a lot of flexibility to do other things that an AV client typically needs to do. And what are the limitations? A modern AV client is not just signature-based engines. Most AV clients, they are comprised of different modules. Like you have, in addition to real-time scanning, you have the firewall there. You might have a separate module protecting the browser. You have behavior-based scanners. You might have dedicated scanners that do other things, like look for rootkits. And those type of scanners, especially the behavior-based ones, they don't really work well through the VMware API, because it's too limited. So that's a big problem. I also wanted to kind of exemplify it, because how does a user or how does a computer typically get infected today? It's not really by file sharing. Let's have a look at a typical example. So if you're looking to, let's say, infect a machine to kind of gain something from it, what you typically do is that you take the easy path. You will look for an exploit kit that does the job for you. What you can do is you can try to compromise a website where you know users are coming to you. That's what we call the waterhole approach. So that's one option. Another is that you compromise or you put the exploit kit on a site and you try to make the user himself go to that site. So how is that done? Typically we see that done by creating a socially engineered email with a link that looks enticing for the user. It could be looking like log into a LinkedIn account or changing password on your PayPal account or something like this. The point is just to get the user to click on the link in the message. And we see the same approach used whether it's targeted attacks. So in that case we would see these emails in a very limited amount and to targeted users only. But it's the same approach that goes if you want to spread a banking Trojan. Then you just send these in large numbers and you hope that someone is stupid enough to click on the link. So at that point, when the user actually clicked on the link, that's when the damage is done. So he goes to the website with his browser, the exploit kit is running there, your browser gives a lot of information when it connects to the site. You can see which version of the browser you are using. You can see, okay, is this a vulnerable version of the browser or not? Then you can probe other things on the client. Is there browser plugins that are poorly updated that could be exploitable, etc., etc. And then eventually the exploit kit finds the weak point, and you're infected. And this can happen as easily, of course, on a VDI desktop as on a physical machine. And here, how do you detect that with file-based scanning? You can't really do it. You can't detect the email that's just a URL. That's not something that the real-time file scanning typically cares about. You can't control the user. He will click on the link if he wants to. And it's very hard to even protect the browser, because some malware, like for instance the SUSE banking Trojan, only operates in browser's memory once it infects it. So it never writes any file to the hard drive. Of course, if it's a virtual machine, we're not really talking about the local hard drive, but it wouldn't typically get picked up by the real-time scanning. So that's the problem, really, that modern malware kind of evades the normal signature-based approach, meaning that security provided by agentless solutions is not really as good as you want it to be. And I included a slide here from AV-Test, one of the independent test labs that actually tested this last year. They took a couple of products that support the V-Shield interface, and they tested them for real-world threats. And this is not to speak bad about the competition, but it is because, of course, these companies also have other products that have higher detection rates, but it's to show you that if you go for an agentless approach, you are compromising on security. That's just a fact. So you have like, well, 70–80% detection of real-world threats. Is that something you are comfortable with? If you are really deploying, VDI across your entire company? Maybe not. So that's kind of been the headache for the IT guy. Like, do I go with a thick client that has all the layers of defense that I need to protect the endpoint with a cost of performance decrease, or do I go with the agentless approach? Get a product that is very light on the virtual machine, but at the cost of lower security. So this is something that has been a bit of a headache for F-Secure as well, because we haven't believed in the agentless approach. We haven't yet come out with a product that supports the Vmware Vision API, because we haven't felt that it offers good enough protection for the endpoint. So, but we also realize, of course, that virtualization is really something we need to deal with. So we have to tackle these environments, and this has now, well, we finally come up with our strategy here, how we're going to do this, and we now have a prototype, actually a concept, which is going to be the product that we will be coming out with this year. That is something we internally now call F-Secure Slim AV, and this is going to be an endpoint that is optimized to run inside virtual environments whenever it is deployed there. But if you deploy it in a, let's say on a physical machine, it will act as a thick client. It will provide all the layers that our client has today, and that Jukka showed has gotten very good detection test results. So why do we call it Slim AV? Well, it's basically to kind of play with the idea that in a virtual environment you want something that really has a low footprint, and let's see, that this might not be the final product name. But the concept is this: when you deploy the Slim AV endpoint inside a virtual environment, and I tried to demo this earlier today in a Citrix VDI in a box environment. The concept that we are using is a hybrid one. So when you install the endpoint in a virtual machine, if it's deployed in a virtual environment, we will run the endpoint without signature-based scanning engines. Where is the scanning actually going to happen? It's going to happen inside a dedicated virtual machine, or a number of these. You can have several of them depending on what your environment looks like. So we're kind of doing the same as VMware offers with vShield, but we didn't want to lock ourselves into that only. So this approach is something that we are going to support across all the hypervisors. At least for the beginning, we will look at the three big ones. So Zen, VMware, and Hyper-V. Possibly also others, but those are the three main ones in the market right now. So we're going to use kind of the what is good in the approach that VMware has, but we're still going to run other engines inside the virtual machine. We're going to have the DeepGuard engine, which is the behavior-based engine. We're going to have the rootkit scanner and the special browsing protection module that kind of looks at what is going on inside the browser. So those are lighter engines, and they need to run inside the virtual machine. But the heavy file scanning part will be offloaded. So we're kind of ending up here between the thick and the thin client. We don't believe in either. Like the real way is somewhere in between. The way we read the market right now. So this is what we're planning to come out with now during this year, and we have a prototype actually of this right now that we are offering to existing customers and partners if they want to kind of have an early view on what it's going to look like. So that's the concept, that's the vision. We want to have, first of all, a product that is easy to deploy. It shouldn't be a headache for the administrator. The same endpoint should be deployable both to physical machines or virtual environments, whether it's just workstations hosted on a Type 2 hypervisor, or if it's a full-fledged VDI environment. And it should be hypervisor agnostic, meaning that we don't lock ourselves into one platform, because we believe that companies will use multiple platforms going forward. It's not going to be just VMware or just Citrix. So that's what we had to show you. I guess, I don't know if we have time for questions. 5 minutes left, good. So fire away.
What about hypervisor protection, like itself, like to protect a hypervisor level solver mechanism? Is there like any plan in the future? What's in the market?
Yeah, that's of course also a good question, and there's maybe not a lot of options for that right now in the market. It's something we have looked at as well. In the Slim AV concept, we are looking at the endpoint, mostly the virtual machines. So we're not looking to protect the hypervisor itself, at least not in the first step here. Best practices, I think right now, if you want to look at how security is done on the hypervisor, one thing you need to think about is the traffic moving between virtual machines. How do you filter that? Because in a hypervisor, it's very easy to move data between virtual machines. But if you're hosting different kind of virtual machines on the same hypervisor, you might want to think about segmenting also the traffic there. So that's one concern. I'm not saying we have a product for it right now, but it's maybe just to give you some thoughts. But it's it's a how can I put it? It's an exciting field. There's a lot of things happening. One of the problems, obviously, is that there's a large number of hypervisors. So for the AV companies, how do we, if we want to protect the hypervisor layer, there's like 15 of these that we should protect, and you have to integrate with each one of them. Some of them offer good integration, some of them don't offer that good integration. That's probably why you don't see a lot of products out there that actually do that well. Is it going to change? Maybe, but that's the situation right now.
Can we expect attacks to that layer?
Sorry?
Can we expect attacks, like somebody to attack to this layer and infecting it?
Like I said, we're not seeing what would I call real world attacks on that right now, but conceptually it has been shown that they are vulnerable. There was one study done, I believe that was for Hyper-V, how it could be exploited, and it's a possibility, and there might be exploits that we don't know about that are in the wild right now, but we are currently not seeing it like with the information we have. All right, other questions? Everyone is waiting for food and drinks. Well, if you have questions, I mean, please come talk to us afterwards. We'll be happy to answer any questions you have. And thank you for your attention.